Hi. All right, shall we get started? Okay. All right, so just for the recap, I hope all of you have familiarized yourself with the data set. We are looking at customer data here. Every row is a customer. We are predicting whether the customer would sign up for the shopping credit card or not. And there are a few other interesting things which might emerge out from the exercise when we see the results. So I want you to follow step by step. What do you think should be the next step? Pivot tables, ideally, but as I said, just for the interest of time, I'm not getting into the research part. We'll just, based on logical sense, try and include some, maybe exclude some. And again, all of you can do different experiments if you wish to. Let's see who can build a much more logical model or higher accurate model. So you're free to ignore, you're free to include whatever variables you think you can, see how it affects the results and so on. But let's do the first trial together with the same things, everything select. Everyone selects the same thing. And then second trial, third trial is your choice on how you change, how you come back and so on. So now that we are not doing pivot tables, what should be the next step? prepare the data. So we should go for missing value preparation, creation of new columns. Hmm. Hmm. We can change that in the prepare also. We can change that here also. Again, yeah, that becomes important if you're considering those variables as one of the important variables. We'll do that in the prepare recipe itself. Okay, so let's come back to the flow and let's go for prepare recipe for the card. We will name it card prepared or whatever you want to name. And let's get into the prepare recipe. Okay, now you should help me step by step. Is everyone with me? Prepare recipe. Let's have a look. Yeah. Yep. Just okay. So you were here. Okay, let's move column by column. Now I will only tell you, and you will tell me what needs to be done. So first things first. Are we looking at sample problem versus whole problem here? Whole problem. So that means no issues. It is 3,000 rows. It's less than 10,000. So that perspective is not there, that you're only looking at a sample. So one drama finish. Let's look at age. Can you tell me how many age values are missing in the column? How many? 30. All right. So in that case, 30 out of 3,000. What do you think? Mode or average, anything. Mode, I think, is also good. Mode would retain the overall distribution. Average might slightly change, but 30 out of 3,000 really doesn't make too much of a difference that you will with any of the methods. So let's stick to one. Shall we choose mode? Mode. Yeah. All right. So go ahead and replace the missing values by mode. What is the mode? 43. All right. So replace the missing values of age with mode. And if you need help at this point of time, that means you're not practicing. Well, this should now come naturally to you. Click on the column age, figure out where that option is, replace missing values with. Let's do it together. So here is age. If you see more actions, you would see fill empty rows with, and I would say mode, which is the most frequent value. And you can click OK. So that should be your step one. With income, how many are there? We'll come to income. Just four. Yeah. So then mode or average both are okay. So make sure that age is step one. We'll do one column at a time. It says double and decimal. Yeah, not an issue. Income. Let's move on to income. That's your step two. Income also has missing value. What do you want to stick with? Mode. Let's do mode. So income. More actions, fill empty rows with mode again. What's the mode of income? 20,000. All right. Yes. Great way of looking at it. And I would say in your coursework too, this is exactly the kind of narration that I want. So now we are just, reaching to a stage where I can show you what decision tree is. Ideally, you should spend time. And in fact, people form categories here also. So they would say, okay, where are these missing values coming from? What job type is it? What age is it? So for a certain age, they would click, okay, what is the average income and fill that as the remaining value. So that's the kind of research and brilliant thinking. So what she's saying is you can look at the type of the work based on the missing values and then take a better guess on what those missing values could be. Excellent approach. Exactly the kind of approach I want you to take in coursework two, where all this forms part of your research. Good thinking. As of now, I'm just, as I said, ignoring the research part, getting straight to running the algorithms. Yeah. Okay. Hmm. 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 Okay. Makes sense. Yeah.
even to this class, I got the same thing for the hackathon, and then like, if you're not getting more return,
Correct.
how sufficient?
Average of manager category. So let's say I do the analysis and do a pivot table where I look at all the job type and the average income for each job type. So let's say the average income for manager is 40,000. So I would actually replace 40,000. That's the best way of it. Because even in manager there is variability. So average of the job type. Very early, sir? I was attending online. All right. Okay. Yeah. Okay, so step one done, replace age. Step two done, which is income. Let's move on to the next one. Marital status, string and text is okay. Job type, string and text is okay. Has loan, boolean is okay. Credit score looks good. Visit to branch looks okay. You were telling about visits to branch, is it? Which it's fine. I mean, it's taken big integer, not required. I mean, you can have integer. Hmm. Analyze. Okay. But you have, yeah. So in if it is categorical, you can have a look like this. If it is numerical, you can have a look like this. So it shows you all. So fine. I mean, all the statistics are coming. Everything is good. Hmm. This one? Yeah, but that's okay as of now. Like I still get a good histogram. So nothing that will stick to integers. Yeah, no problem with that. Because you don't want it to be categorical purely, and I mean you would want to see whether visits of the branch individually makes a difference. And since these are smaller numbers, if I see it 1 to 10, okay, not an issue. Average online spending, double decimal looks okay. Emirate looks okay. Children is fine. Okay, now let me give you a tough task. Total years in UAE also is fine. And our main dependent variable is Boolean automatically, yes or no. So which is also okay. It can be Boolean, it can be string or text, which is categorical. So Data IQ picks both quite um, comfortably. So, let's see. Yeah, these are number of children, right? So integer. It's not categories that type one, type two, because let's say if you want average number of children, so you can still calculate that. So nothing that would disturb the analysis here. So it looks okay. And again, you can change it as far as whatever you are comfortable with. I would retain because it does not cause any difference in the analysis. Okay, now let me introduce step number three, which is where I would recommend you using GPT, Claude, or whatever. Now, let's keep it simple. Maybe later you can try more complications. Um, Let me pick up some keywords from in general. Let's do Amazon. Let's do noon. Let's do booking.
Talabat.
And let's do Zomato. Four things. Listen carefully. Noon, let me type it down. Noon, Zomato, Amazon, and what was the other one? Booking. We'll just use booking. Online student, someone was asking something.
Sir, I said Talabat.
Yes, we can stick to four. You can experiment with that later. Talabat is also valid. Okay, so here is your task. Listen carefully. I would recommend using a formula, and I would recommend asking GPT to prepare that formula for you, unless you're confident to just ask which function can help you do that. But there will be or and all that. So I would recommend going for Gen AI to give you the formula. And what should you do is you should create another column called uh, category shopping. Okay. And if the shopping interests contains one of these keywords, which is Noon, Zomato, Amazon, or Booking, contains one of these, then the category should be yes, else the category should be no. We'll keep it simple. If one of these four categories are present, then your new column should reflect yes, else the new column should reflect no. Anything, let's say category shopping, give any name that you want. Shopping category, let's say. That should be the name of the new column. Best to do a GPT or Claude and then ask that there is a column like this called shopping interest. And if the text contains one of these four keywords, then it should be yes, else it should be no. I will also search the same on GPT and check what it gives. 5 minutes to do this task. Amazon, Noon, Zomato, Amazon, and Booking. So it's a simple yes or no. Done? Okay. Once more. Noon, Zomato, Amazon, Booking. Just be careful with the capital. So in the shopping interests, I think, or the caps are used. Capital N for noon. I think Zomato is also capital Z. B is capital B, and Amazon is also capital A. So I could build the whole formula with GPT. Of course, be careful. GPT might give certain formulas which are not relevant for this. So, and the name of the existing column, you should also be careful. How many of you have completed? Okay, nice. And I see the formula. Sorry. If else itself, okay. Oh, then you maintain the whole thing. All right, that's fine. Anyone who did anything else other than if else? Can use the formula directly instead of if then else. Formula? Okay, which one? If, yeah, perfect. Right. If you're not getting, don't worry. We will do it. I will share the formula with you. All right, let's do this. You can choose if you're doing if then else, then you can choose if then else. The only problem with if then else is you have to be very careful which one are you putting where and what is the else part and so on. I would rather prefer, and everyone, please, this is very important for your hackathon as well because you want quick results. And with AI, why not take help of AIs? Everything is good. So how you should be prompting at this point of time if you're using GPT. So everyone, please be careful. I'm not going for if then else. Even if you have used if then else, have a look here because later you probably will have to come up with formulas that you don't know. So the best way is to prompt GPT and inform that you're using data IQ. Number one, you have to inform GPT. It will not understand which tool you're going for. You have to give the exact spelling of the column and you have to say this is my column name, which is shopping underscore interest. Okay. And then you have to give your prompt. You have to say, if the shopping interest has the following keywords, which is known Zomato, Booking, and Amazon, then the new column should be yes, else the new column should be no. And don't blindly copy and paste, just check everything, whatever the GPT is giving. And for me, when I ran the prompt, it did give a formula. So let's first see where to put in the formula. So I'll click on shopping interest. I will click on more actions and called process with formula. If you're using if then else and if you're comfortable with that, no problem at all. Otherwise, click on more actions, click on process with formula. And once you see process with formula, a new step will open here. It will say, what's the name of the output column? Let's name it. I don't want to replace it. So I will name it as a new category or shopping category, whatever you want to name it. And then I will say, click on open editor panel. Okay. And that's where I will start putting in the formula that ChatGPT gave me. If at all you don't want to put the formula and you want to try yourself, you can try on your own. If and then there is a or function which can combine multiple things together. And then there is a contains function which tells you whether a string is contained in another string or not. But why get into all this when GPT can give you the function itself? So when I ran on GPT, it gave this, which is very simple, which is the correct one also. And you can try this until you get this. So I paste it here. There you go. It directly gave me this formula. If or and then contains shopping interest noon. So basically it's combining all these four into an or operator. If the answer is yes, then yes, else it is no. And it works 100%. If you're not able to prompt it, at least now you can prompt GPT that use only the following functions if contains an or and give me the formula with nice brackets and everything. It will frame the formula for you. Just copy and paste. Before you apply, check your preview if you are getting. So, for example, in the first one, there is booking. So it is yes. In fashion brands, groceries from Spinneys, it's a no because none of these words are there.
So I
Yeah.
have pasted a formula in the chat. I think it's gonna give the same result if you can check
Yeah,
once.
yeah, absolutely. And there are multiple formulas contains. Yes, that's the
It
or
depends.
operator, by the way. Yeah.
Yeah.
So, guys, that's a good point. It's not just one formula that applies. There is a or operator if GPT is giving you that, and with that also it works. There's a contain like or could be used as a function. There are various ways. Whatever works for you, just apply. Check. I mean, don't apply. First, copy and paste the formula. Make sure the variables are picked up correctly. Make sure the syntax is valid and just make sure that you're getting the preview right. Yes or no? And
And
if
so
you, yeah,
one more
yes.
thing,
Hmm.
like here we just figured out by overlooking like known is in capital N, but
Correct.
if the data is huge and maybe
Hmm.
then and known is in small.
There is a formula which converts everything into lowercase or converts everything into uppercase, and then you could use a contains. So
Yeah.
you'll have to use one more formula in that case. Correct.
Okay.
Yeah. And for those who are online, I can put my formula also in the chat. You could use any one of these, all are the same. And those who are here, let me know if formula doesn't work. Okay, yeah, I see. Yeah. What formula are you trying to with GPT? Use it. No, did you mention you're using data again? So I don't think. Okay. Did not mention what's your column name. I want to add a column. You didn't mention the column name, so I'm better to use GPT. And mention the name of the column is shopping interest. Name of the existing column. Shopping interest. Make this correctly capital S, which will or you can call it. If this fixed. Then just mention no, but don't use lowercase. You done? Yes. Okay. Four, one. Okay. All right. Yes. Restart. No. If or uh, need the we have GPT. No? Okay, this
I just like,
better to format it because there are many brackets and everything. So just ask GPT use if or and contains and give the prompt. Yes, you're good. So yes. So which method are you? Okay, sounds good. So first of all, you need to give a new name to the output. Okay, so name and address. Name which option you can select? You do so many touch. Right? That is your. It should be okay.
Sir,
Just the formatting. Gemini is not very okay. Yep. Yes. Online students, yep, tell me.
Professor, when I copied the formula from
Mhm.
Claude,
Mhm.
it's saying parsing error when I correct when I.
You can just copy the one that I put it in the chat.
Okay, thank you.
Yeah, just delete it and put this. Yes, who else has not done then? Yes. Yeah, that's fine. That's fine. Different ways of handling, and the only problem there is capitalism and capital, right? So you can choose that change it to capital, change the configuration. Yeah. Okay. All good? You still pressing on your own? Better because there's a lot of brackets and formatting. So
Yeah,
let's-
I did.
Yeah, fair.
Yeah.
No, so this is Python. You didn't mention data.
I did mention it.
First mention the column name is.
That might make us continue to GGD that.
And capitalize shows the letter and in the front first letter on. Yeah, and then
We have a new store.
sir, college I no. We generally use for data science we have the Amazon and Google account, which gives you like $100. I don't think for business we have it. We'll see. I think we have to.
If we are in.
Hackathon free is more than enough. Yeah, with just one or two formulas you would need, and even if you go on. Yeah. That's because. Click a plan. That's yeah. And all right, so now we have a new category, and again, this is something that you should develop as a practice. Everyone, please pay attention. This is something you should develop as a practice in terms of prompting nicely, telling data IQs what you're using the correct name of the column. Don't blindly copy and paste everything that GPT is giving. Out of all the LLMs, I would say don't use Gemini. It's not very updated with data IQ. Claude or GPT does the best for understanding. It's pre-trained already with data IQ. So don't use Gemini would be my recommendation. Or either GPT or Claude for any of the formulas. Again, if you can do it on your own, there is nothing better than that. But when too many brackets and everything comes, then you start getting confused. Another way is you do it yourself. And just for the formatting of the bracket, you can paste it in GPT and say, can you format it with the proper bracket? So lot of ways in which you can customize the formula. But again, just make sure that you're prompting everything correctly, making sure that you see some of you are not even seeing the steps. So keep a track. This was step one. This was step two. Now you're on step three. If you make any mistake in any of the step, you need to delete that step, particularly for two of you. Yeah. You didn't see that there was a step three in between, which was causing a problem. So always keep track, apply proper changes, make sure you're naming your columns properly. So everything will be on track. Question, online students, this IFSA, was that the previous one?
Yes, at the previous one.
Okay, all right. So let's go ahead and run the changes that we did. And let's come back to the flow and I'll give you then the next task. So in my case, data preparation is done. I have a card prepared. Come back to the flow, verify that the changes are done. So right now we are running the changes. Prepare recipe is done. Make sure you come back to the flow. Make sure there are two blue boxes that you see, and let me know if anyone has not seen. All done? Anyone needs any help? All right. Moving on. Now your next task is a bit complicated because I want you to find a new option. Listen to it very carefully. Now that the prepared stage is done, what do you think is the next step before running the algorithm? What do we do? What did we do in logistic regression? Split it into training and testing. Okay. Now, here is your task, and listen very, very carefully. This time, I want you to split a bit differently. Okay. Last time, do you remember how did we split? Random. 80% went to trains and remaining 20% went to tests. This time, what I want you to do is use the same recipe, which will be split, where you split it into train and test. The only difference will be in train, you'll have to do the following activity, and listen to it very carefully. First, you need to sort the customers with with customer ID. I repeat, you have to sort the customers with customer ID. Okay. And the first 80% of the sorted IDs go in train, and the last 20% goes in test. It's not random. I repeat. Let's first see if the data is already sorted by ID. Let's check. Let's check customer ID. Yeah, it's already sorted. So which means what I'm trying to do is first 80% goes in train, last 20% goes in test. Let's see. Nothing extra to be done. It's just the method of split. Still the recipe remains the same. You must use the split recipe, name it as train and test. Everything is the same. Go ahead, use split, name it as train and test. If you're not confident, wait for me to do it. And then once you are inside the recipe, last time we chose random as a method of splitting. This time I'm going to sort the customer ID, and the first 80% of the records will go to train. The last, sorry. So in the sense, it's already sorted. So basically I can choose, for example, I can sort by age. And I would say, okay, if you have sorted the whole thing by age, the first 80% is going to train and next 20 is going to go by test. Done?
And before applying them.
Let's check. That's correct. That's correct. Good job. 80% train, 20% test. Who had question? Yes, that. Which one? Or the can you show me the recipe? No, just show me the recipe. Yeah. Salt, ready? Perfect. All good. Yeah, I'll show you. Now that's not very complicated. Let's do it. So I click on prepared. Make sure it's clicked on prepared. Everyone, I'm doing it now. Please have a look. Guys, I'm doing it now. So click on prepared, click on split. And name it as train should be first. Test should be second. Make sure you have prepared. You have train and test as the two output data set, and click on create recipe. Last time, which option did we choose? We chose randomly dispatched data. This time we are not going to do that. We will do the last option, which is dispatch percentiles of sorted data. So let's click on that. Now it would say, how do you want to sort the data? According to which column? According to age, ID, or what? So we'll select customer ID. So it will sort, it's already sorted, but it will sort it again in the order. And then Let's, you can choose few more options that after sorting from customer ID, sort according to age, sort according to that. But we just need one sorting, all done. And we'll make the ratio as 80%. Done. As simple as that. So 80% after sorting goes into train. The last 20% goes into test, a different training and testing strategy. And again, in hackathon, we can specify that. We can tell you that in this case, you have to do let's say a sorted split, you have to do a random split. In your coursework too, you try everything. You try sorted, you try random, see if it's making a difference. So that's part of your research in coursework 2. And that's it. I click on run and get ready to run my algorithm. Just double check everything. So when you double click on train, you should have 2,400 rows. When you double click on test, you should have 600 rows. So it got split into 2,400 versus 600. Anyone who did not get? Need help? All good? That's it. Train and test, yeah, all good. Run it. Go back to the floor. Yep, all good. Yep. Time to run decision trees and see how this model would turn up. Where would I run decision tree, on train or test? Train. Let's click on train. And which option? Now you know the option. Auto ML, which is in lab option. So click on train, click on lab. Let's click on auto ML prediction. And what are we trying to predict here? Signed up CC. That's the last column. That's what we are trying to predict, which is whether a customer signed up for the credit card or not. And which option now? Choose algorithms, correct. We are going to choose our own algorithm. You can name your analysis if you want to, or just retain the name, does not matter. So I can call it, today we are doing decision. Mostly because these are for, if you have to build a quick prototype, it will suggest, again, if you're doing deep learning, you can choose that. Choose algorithm as the most comprehensive thing. So even deep learning, you can choose here, even the prototypes you can build here. Everything can be done in choose algorithm. So always for you in the module will be choose algorithms. So that's when you have your own algorithm. So let's say you have a code which you have made a different form of decision tree with some other mathematical indicator. You can use your own estimator model and then bring it inside. But no one is doing a PhD here, so we'll use existing algorithms. Okay, so that's it. And now we are in the design stage. Remember the design versus results. It's exactly the same. Let's start from where we usually do. Let's go to target on the left hand side. Make sure that signed up CC is selected as your target. That's what you are predicting. What should be the next? Before that, train and test. I would love to make sure everything is correct. Now, do you think the policy is selected correctly? The policy of train and test, by default, it has selected split the data set. Yes, same thing as logistic regression. We have already done it, so we don't want them to do it now. We have already done train is separate, test is separate, everything is good. So I select on policy and I click the third option. Explicit extracts from two data sets. I can put train to train, test to test, and everything should be good. So when I do that, train is train, sampling. Should I do any sampling? No sampling. And again, even if you leave it, it's not a big problem because it's taking what, 10,000 rows. We have only 3,000, so it shouldn't affect. But just as a good practice, say no to sampling. So train is trained. Let's come to test. And let's click on test. Train goes to train, test goes to test. Even in test, I don't want any sampling. So I would select no sampling. And just make sure that train is train, test is test. Everything is good over there. Now let's come to what Aisha had mentioned, which is features handling. Let's click on features handling. Customer ID switched off. Should it be switched on? No, we would never take ID. Age are we taking? Yes, let's go ahead. Income are we taking? Yes, let's go ahead. Marital status? Maybe. Yeah, let's keep it on. Job type, we'll switch it off. I don't want job type right now. Has loan, we'll keep it on. Credit score, we'll try. Visits to branch, no, I would not want that. Average online spending, we'll keep it on. Emirate, I mean, let's keep it off. Later in your trials, you can try again with Emirate on. As of now, let's keep it off. Children, no, let's keep it off. In the trial, you can keep it on. Shopping interest is anyway rejected because it was a text variable. And this new thing that we have created, which is shopping category, we would want to keep it on. And again, I'll tell you once we see the results on what you should be careful about. But right now, shopping category, I'll keep it on. Total years in the UAE, maybe. So let's keep it on. That's it. Let's move on to algorithms. Logistic, I'm switching it off as of now. Later, you can, in your second trial, maybe you can switch it on. But if you want to run both together right now, you can do that. I'm going to switch on decision tree. Random forest, maybe in the next trial. Let's only run decision tree. In the next trial, you can switch on random forest as well as logistic regression and then run. Right now, let's focus on decision tree. Then it will be your homework. You can try logistic regression, compare the results, and so on. What else? That's it. We can save and we can train. We'll call this as trial 1. And we can train. Yeah. That's fine. I'll tell you later what the options are. Everything is done. Yeah. People, like even in logistic regression, did you see the coefficients on the front screen? No. So we click inside the algorithm, we see the detailed results. Right now, these are front results. Just like logistic regression, these are the results that come in the front. What is the first thing that we notice? What you should notice right now? First thing that you look into.
Income is helping a lot in figuring out.
Yeah, even before that. 0.912, the champion icon over here, that tells you that it took your decision tree, it ran it in your test data, compared with the actual results, and the accuracy turned out to be 91.2%, which is a great accuracy compared to the fact that we haven't done much. We didn't experiment much, we didn't do too much of data prep. Even without anything, 91% accuracy, it looks like. If you look at based on the tree, what data IQ is interpreting is income, total years in UAE, and has loan are probably the top 3 variables at this point of time. Not necessary. I'll tell you what the depth is. He also asked the same question. Can I reserve this question till we see the results? I'll talk about what depth is. Depth does not correlate to the number of variables. It is the number of levels of the tree. So in one level also you can have 6 variables. Left hand side, there could be something. Right hand side, there could be something. There could be 4 here. So the levels are basically level 1, level 2, level 3, level 4, level 5. And I'll tell you why they keep a cap of 5 and why you may not. I'll talk about the depth. So as of now, I see which variables are the top variables. But as Aisha said, I don't see the tree yet. Where do we see the detailed results? We click inside decision tree. And then you see everything that you should see. And you notice a difference. In logistic regression, when you went inside the results, instead of decision tree, it was regression coefficients. You don't see regression coefficients here because there is no beta x1 plus beta x2. There is no equation. However, now stay with me, everyone. Few things remain the same. Number one, what if analysis? Exactly the same. Choose a profile of a customer, live predictions you can see on whether the customer will sign up. And this is great for the bank. So I would say, okay, there is a customer who has no loan, who has an income of 46,000, whose online spending is this, whose credit score is this, whose total years in the UAE is this, so on and so forth. And you can keep on changing the customer profile. And for that customer, you get a live prediction, which is whether the customer will sign up for the credit card or not. Guys, please do that later. First stick with me. Questions on this? Correct. Now, this is where again I told you this is not the actual probability of the algorithm. It's an interpreted probabilities based on the tree, on how much was split on the left side, right side. In decision tree, I wouldn't consider this as a great thing. I would only say yes or no is the main thing. It's an interpreted probability, not the actual predicted probability. So I have to be a bit careful over there when I see that. For those of you who are wondering, where is the tree? Here is the tree. When you click on decision tree, and I don't think it's a complete tree, you can expand all and then see the whole complicated tree. And again, you see it started with has loan. So has loan appears to be one of the very important one. Income appears to be important one. Average online spending appears to be important. And then all the drama of look at this, look at that, and so on. And then finally, you get a prediction of a red or a blue. Blue stands for yes, red stands for no. The complete if else, if else, if else is already ready. I would also look at confusion matrix, very important parameter for me. There were 600 rows in my test data. Actual predictions were 529, and I mean actual thing was 529, and the real one was also 529. There were this green. Actually, the answer was no. Predicted answer was no. There were 28, and 37 plus 6 was the error term that or the errors in the prediction. And that's why the accuracy came out to be 91%. Nothing changes. So that means they were not important at all. That's how you experiment. Now you add, you delete, you say, okay, what can be added, what cannot be. Now, one question, and again, I leave all the experiments on you. You can try logistic, you can try random forest. But at this point of time, as an analyst, looking at that matrix, I'm a bit concerned. This is what I want you to work in coursework 2 as well as a hackathon. So, yes, the output came, 91% came, thing looks good. I am a bit concerned. Threshold number 1, yes. Now, again, as I said, probabilities and decision tree won't make too much of a difference. But yeah, that is a very weird threshold to say 0.05. And obviously, you know why Data IQ has done that, because it wants maximum accuracy. Now, does that probability threshold actually make a lot of sense? No. But does that change a lot of things? No. I mean, slightly accuracy gets compromised, but not too much. So not too much of a concern. Still, there is a big concern. What is that? Correct. Correct.
Almost like a 55 to 45% of
Yeah. So let me explain. Very close to this. Let's do one thing. Let's come back to yeah. 0.5. Okay, let's come back to where your results were. 0.05, right? These are your results, correct? So now I would look at this and I would say there is only one problem here. Majority of the predictions are yes. Have a look. Now, if you see out of 600 and see this column, predicted yes, it has predicted 566 as yes. And someone who would come here and ask you a very interesting question. They would say, forget about your model. Why did you do all this drama? I have a better model for you. And you want to listen to my model? I would say everything is yes. Give me whatever customer, I would say they would sign up for the credit card. Even with that model, I could achieve great results. Are you getting my point? Now the problem is that out of 600, the actual yes were already 529. And this is not a great test data set to play with. Ideally, if the test data set had equal number of yes or no, only then the algorithm can show its real power. How much of yes is yes, how much of no is no. But now, out of 600, if your actual yes, in fact, how many are total actual yes? 535. Out of 600 are already opting for the credit card. Then what great power the algorithm has. In fact, I don't need decision tree. I have my own algorithm which says every time it will be a yes.
how that is.
And it is so which one?
So the existing data,
Hmm.
if 535 out of 600 are saying yes,
Hmm.
then the algorithm is trained on the data.
But this is test data. This is test data. It was not trained. So the problem is now I would sit back and think when we split the data, did it so happen that majority of the yes actually came down in test? And I would say maybe my splitting was wrong. I should have done a random splitting here so that my test data had a good mix of yes or no, and my trained data also had a fair mix of yes or no. Even if that doesn't work out, I would say, can I reduce my training data a bit to make sure that test data has enough number of yes or no? Or maybe I could change the split strategy completely. I could say do a stratified split, which means in the trained data, maintain the ratio of yes or no. In the test data, maintain that ratio of yes or no. As of now, while you can be happy and you can say, job done, I got a 91% accuracy, my model is great. It is not because there are only 65 out of 600 who did not opt for the credit card, which is partially okay. The other argument is yes, there are only 65, but out of that, 28 were correct predictions of no. So someone could also say, no, there is some merit in the model, but I wouldn't be extremely happy because it's heavily biased. And this is how analysts should think. It is heavily biased with the actual predictions being yes. So can I go back, change the testing and training strategy, make sure that it's not like there can be majority, yes, there's no problem with that. But extreme majority, like 535 out of 600 is already yes. And if the model is also predicting already yes, it might not be a superb model. And this is where I would raise question marks. Unlike the Titanic one, where there was a good mix in all the things. Yes, yes, also there was good numbers. No, no, also there were good numbers. And that looks okay. The model is doing a fair job in predicting a yes or no. Here, majority predictions are 566 out of 600 are yes. But that does not mean the model is bad. The model could have been bad if this was zero, which means there were no predictions in the no category at all. Right now, at least there are 34 predictions in the no category. So it has some merit, but I have to be very careful in seeing this biased nature. In fact, what I would do, Utkarsh,
Yeah, so when I check the data which we worked on, so the no percentage is like 10 only.
exactly where I was coming to. This is exactly what I was telling. In fact, what I would do next is go back to my data and check how many are yes and how many are no at the first place. And some people get too curious. Now what they say is, look, this is a heavily biased data towards yes already. Can I make a smaller sample of this data? So, can I have, so let's assume what percentage you said is no. Let's see the actual number.
10.5.
Okay, so let's see the actual number. Let's go back to the flow. Let's see card prepared and let's see the last column. And that's how analysis is usually done. So I go to analyze. I see there are 2,682 yes and 318 no. One strategy that I can do is maybe form a sample of 900 or 1,000, where I take all the no's, definitely 318, and reduce the number of yes, and then try and run a model. That would increase the percentage, that would reduce the sample, but increase the percentage of no's compared to the yes. That gives a fair chance to explain, is the model really doing good as a model? Or is it doing good because the data is in such a way? All this is part of research, right? And this is exactly the difference between coursework and hackathon. In hackathon, you wouldn't go so much back and forth, but in research, in fact, I can tell you honestly what will happen now. Majority of the models that you run, you will see 95%, 99%, and you will think job is done. There are problems. There are some things which are leading to that, and that's what we want to know. So see my strategy now. I will retain 300, and from 2,682, maybe around 500 I would sample. Total around 800, 900 records. Let's run a model, same model on a smaller sample, but significantly larger percentage of no, and then check, do I get the same accuracy?
Can't we do random sampling in this?
Random sampling you can try, but as Utkarsh said, originally itself it is so low. So even in random sampling, very high chance that again your no thing would be really low.
So, 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 so
So
should,
percentage should still remain 80-20. So that's not a thing. The original sample, which means when I reduce the sample size here, can I make another data? And again, you can use a recipe where I retain the nose and then take probably half of this or maybe 40% of this and then make a data and then run the model on that. A lot of experiments can be done. Yes, someone online was asking.
yeah, so I'm saying that if we are doing this, then if we're taking, see, no is 318,
Hmm.
shouldn't we take yes as like 318 exactly?
Not exactly 318, but maybe even more than that. So it need not be 50-50, but it should not be in extreme minority.
But
So
if we
even
take 50-50, then won't it make it learn more precisely? Like if
no,
we
but
take
then the number of training rows will reduce. So let's say you take only 318 of yes. So total sample is only 600, correct?
yes.
Yeah, so I wouldn't want to risk that. So maybe instead of 300 yes, I would take 500 yes or maybe 600 yes, which would still give good percentage, but not lower the sampling so much.
Yeah, okay.
Yeah, good question. So, yeah. So resampling is now you can't do with a split. Now what you have to do is there is a filter recipe. Sample and filter. So from the filter, you would randomly take some percentage of the yes and retain the complete no, and then make a reduced sample, which you can try. You can do it in the original data itself, the prepared one, and then do a training and testing of once you make that new sample. Multiple options. These are all different pathways. But as an analyst, I would love to check. I'm not completely happy with what I see here. I would love to recheck whether the model truly stands on its own or is it because of the biasness of yes and no. With that, we come to the end of the session today. I leave other things on you. Try logistic regression, try random forest, rerun, see if you can notice the differences, try and include, exclude some variables, lot of ifs and buts. But now you know how to run a decision tree. Thank you so much. I'll see you all tomorrow.
Can you sample in this, like, you have to put it in an algorithm?
No, so there's a recipe called filter and sample from where you can. I can show you next class. We can do that. Any other questions? Anyone couldn't do this part? All good? All right. Thank you.
So I have
Yeah.
one question.
This
So
one. Yes.
when we'll be doing the coursework,
Hmm.
then should we be doing the preparation on the whole data set or just the sample?
Whole data. Definitely whole
Okay.
data. And then see if you can rerun the model with the sample if required.
Like we figured it out that the whatever we were figuring out, the majority was yes,
Hmm.
and so we will resample it again. Like
Exactly. If required, resample.
if
From starting itself, we don't.
okay. So will
Yeah.
you be telling it this in the next class? Like
Yeah, I can show you the sampling. Yes,
okay.
definitely. Yeah.
Thank you, sir.
Okay.